Students of class 11, today we are going to discuss the example 2.6, in which there are two clocks and whose reading are given day wise from Monday to Saturday, and then we have to find that which of the two clocks will you prefer, means which of the two clocks are more accurate. Now when we consider the accuracy, we can ignore the zero error. Zero error means if the starting time is different, but otherwise the time time duration is mentioned very accurately, then that type of clock will be preferred, rather than if some clock is having zero error, nearly no zero error, still the time gap is not maintained by it, so that clock should not be preferred. And therefore, if you see the variations in the range of variations over the 7 days for the first clock, you see that it is 162 seconds for first clock and 31 seconds for second clock. So that means the second clock is having least variation in time, and therefore it should be preferred, it is more accurate. So therefore, though the second clock is having large gap at 12 o'clock, you see the cutoff, the 12 o'clock the reading is 10:15 and 0 second, whereas it should be 12 o'clock, but that difference is constant, it is zero error, and that can be ignored or corrected. Now let us look into the another example 2.7. It says that we measure the period of oscillation of a simple pendulum, which are successive, with the successive readings are 2.63 second, 2.56 second, 2.42 seconds, 2.71 second, and 2.80 seconds. Then we have to calculate the absolute error, relative error, and percentage relative error. Now you see the mean period of the oscillation of the pendulum can be found by adding all those 5 readings and dividing it by 5, and that gives you the true value or mean value of the readings. Once we get the true value, now we want to find the absolute error. Now the absolute error is the sum, the difference of the two readings, their magnitude taken, means which one is greater, which one is smaller is not considered, the difference is taken positive part only. So the absolute error in the measurements are calculated and found to be 0.01 second, 0.06 second, 0.20 second, 0.09 second, and 0.18 second. Now the errors in this case, we have found the absolute errors. Then we have to find the relative error. Now relative error is the ratio, relative error is the ratio of mean absolute error divided mean or true value. So the mean of all these 5 absolute errors is found to be, mean or absolute error is found to be 0.11 second once we add all those absolute errors and divide it by 5. So we get the mean absolute error. Once we get the mean absolute error, we divide it by the mean value which we have just calculated. The mean value or true value of the time period of oscillation was found to be equal to 2.62 seconds, and therefore if we divide 0.11 by 2.62 seconds, we get the ratio equal to 0.1, and therefore the expression for time period of pendulum could be written as the true value, that is 2.6 plus minus 0.1 second, that is the error part, relative error. So this is how we express the error part. And if we want to find the percentage So the relative error is 0.1, and if we want to find the percentage of relative error, then 0.1 divided by 2.6 into 10 power 100 into 100 equal to 4%. That is the relative percentage error. Thank you and have a nice day.